All right, so here's where we left off in our unit circle. We were trying to find these terminal points for all of these angles around the unit circle. There's certainly not all the angles in the world. Not everything happens in multiples of 30, 45, and 60 degrees, but these are a good pile of angles for us to get our brains wrapped around what the sine and cosine functions tell us about angles and distances. All right, so last we left off, I had told you the terminal points for 30, 45, and 60 degrees, and we're gonna use some symmetry to fill out the rest of the unit circle. Okay, so notice that all of those red spokes around the unit circle, they kind of have a mirror reflection property with the 30-degree angles. They're all the angles that are either 30 degrees up or down from the x-axis. Okay, 30 degrees or pi over 6 up or down from the x-axis. All right, so it's going to be easy to figure out their measurements, particularly in degrees. Okay, so let's see. In the second quadrant there, I'm 30 degrees shy of 180, so that's going to be 150 degrees. Okay, the one in the third quadrant, let's scoot this up a little bit. I'm 30 degrees more than 180 degrees, so 180 plus 30 is going to give me 210. And then in the fourth quadrant, let's see, I'm 30 degrees shy of 360 degrees. 360 minus 30 is going to give me 330. Okay, so I could just convert all of those red degree measurements into radians and know what their radian measurements are, but I want us to get a little more sophisticated about the way that we think about these radian angle measurements. All right, so let's take a look at pi. We all remember where pi is on this unit circle. It's 180 degrees. I'm going to think about pi as being 6 pi divided by 6. Okay, and I'm doing that because I'm in my red pen and I'm talking about a pi over 6 angle. All right, so that's equal to pi, right? The 6's would cancel. All right, but if that's 6 pi over 6, and I'm trying to get up into the second quadrant there, okay, I'm going to be 1 pi over 6 angle shy of 6 pi over 6. So 150 degrees is going to be 5 pi over 6. All right, so if that's 5 pi over 6, 6 pi over 6 is at pi. The next pi over 6 down there in the third quadrant is going to be 7 pi over 6. All right, and that's the same thing we would get if we multiplied 210 by pi over 180 and did all the fraction reduction. So let's move on to 330 degrees. We know that a full revolution is equal to 2 pi. So I'm going to think of that 2 pi as being 12 pi over 6, right? That would reduce to 2 pi. So I do that because, okay, here's 12 pi over 6. The full revolution is 12 pi over 6, but I'm missing 1 pi over 6 to get to that 330 degree angle. So that's going to be 11 pi over 6, just missing a pi over 6. All right, so now we've labeled all the angles. Let me erase all of this extra stuff I've got here. And we want to put terminal points on there. And this is going to be super easy to do. We're going to do it exactly by symmetry. Okay, so look at the 5 pi over 6 terminal point and the pi over 6 terminal point. Okay, they are exactly the same height above the x-axis. So they're going to have exactly the same y coordinate. Okay, so I'm going to copy the y coordinate as 1/2. The x coordinates are the same distance because they're the same angle above the x-axis, except for, let's see, pi over 6, 30 degrees, you're going in the positive x direction. For 150 degrees, you have to go in the negative x direction. So the coordinate is going to be the negative √3 over 2. All right. As it's going to turn out by that same symmetry bit, the x and y coordinates are going to be exactly the same numbers for all of those 30-degree angles. All of the red spokes, they're going to have the same x and y coordinate. You just have to make sure that you get the right positive or negativeness on them based on which quadrant they're in. If you're going to get into the third quadrant for 210 degrees, you're going to have to go negative in the x direction and negative in the y direction. So this point right here is going to be negative √3 over 2, negative 1/2. And then for 330 degrees, we're going to get, let's see, I have to go positive in the x direction, so positive √3 over 2, and I've got to go down, so negative 1/2. All right, we're going to do the same thing for all of the blue spokes for 45 degrees and all of the purple spokes for 60 degrees. All right, so let's switch over to our blue pen and do all the 45-degree angles. All right, so 45-degree angles, those are all the angles that are up or down 45 degrees from the x-axis. All right, so in the second quadrant, 180 minus 45, that's going to be 135. Let's see, in the third quadrant, I'm going to have 180 plus 45, that's going to be 225. And in the fourth quadrant, 360 minus 45 is going to be 315. Okay, for our radian measures, I'm going to do the same thing I did before. I'm going to think about everything that I know as a pi over 4 angle. So pi over here, I'm going to think of that as 4 pi over 4. The 4s would cancel and give me pi. So if I'm going up into the second quadrant, I'm 1 pi over 4 short of having 4 pi over 4. So this is going to be 3 pi over 4. Down in the third quadrant, 225 degrees. Okay, I go all the way to 180, 4 pi over 4. One more pi over 4. That's going to be 5 pi over 4. All right, for 315 degrees, we're going to remember we've got a full revolution. That's 2 pi. 2 pi I'm going to write as 8 pi over 4. Okay, so matching the denominator to the angle that I'm working on and just rewriting it with the common denominator. All right, full revolution would be 8 pi over 4, but I'm missing 1 pi over 4, so that would be 7 pi over 4. All right, now that we've got all of our blue spokes labeled for all of our angle measurements, we're going to copy that terminal point. They're all going to be square root of 2 over 2, comma square root of 2 over 2. We're just going to make sure that we got the right negative signs on them based on the quadrant they're in. Okay, so 3 pi over 4, we're going to do a negative x coordinate, a positive y coordinate. Down at 225, we're going to make both coordinates negative because we're down in the third quadrant. And fourth quadrant, we need a positive x coordinate and a negative y coordinate. All right, one more set of terminal points to go. All right, so let's see. Now we're looking at all the things that are 60 degrees away from the x-axis. So 180 minus 60 to get up into the second quadrant, that's going to be 120. And down in the third quadrant, 180 plus 60 is going to be 240. And then in the fourth quadrant, I got 360 degrees minus 60, that's 300. All right, and then we'll do our trick to figure out all of the radian measures. So here's pi. I want to think about that as a pi over 3 because we're doing purple angles and that's pi over 3. So I want to think of this as 3 pi over 3. I've got 3 pi over 3, missing one of them will give me 2 pi over 3. Okay, 3 pi over 3, go one more pi over 3 into the third quadrant. You can have 4 pi over 3. And then 2 pi would be our full revolution. 2 pi, if I write that as something over 3, it's got to be 6 pi over 3. All right, so full revolution is 6 pi over 3, missing 1, I'll give you 5 pi over 3. All right, then we're going to fill in all those terminal points with 1/2 comma root 3 over 2 with the right positive or negative sign. Okay, so let's see. Negative 1/2 comma root 3 over 2. Down here, let's scoop my paper up a little bit. So here I'm going to have both coordinates be negative, negative 1/2, negative root 3 over 2. And then over here, positive 1/2, negative root 3 over 2. Okay, so all of your red angles should have the same numbers, all your blue angles should have the same numbers, all of your purple angles should have the same numbers. And then just double check, second quadrant, all of my x coordinates are negative, all of my y coordinates are positive. All the coordinates are negative in the third quadrant. In the fourth quadrant, all the x coordinates are positive, the y coordinates are negative. All right, so that is a beast, and it is a beautiful tool that's going to help us to do so much with our trigonometric functions when we meet together in class.